Hi, welcome to today's video. Today I will be explaining about machine learning. All right, so I'm Muhammad Razi bin Jamsuddin. Today we will went through the introduction to machine learning. All right, so machine learning is the study of computer algorithm that improve automatically through experience and by the use of data. For example, you have an algorithm that is dependent on past training data. Right? Um, let's look at the intention of using machine learning. So imagine you have created a machine learning and you want the machine learning to do some sort of classification or prediction. Before the machine learning can actually do some of the thing that you intend it to do, you need a sample data or past data that is known as training data. This training data will help the machine learning algorithm to build a model in order to make predictions, decisions, or classifications. Machine learning algorithm can be used in a wide variety of applications, such as face recognition, email filtering, computer vision, such as biometric identification, where it's difficult or unfeasible to develop a conventional program. Okay, however, there are some of the uh, things that we need to consider before we can create our own machine learning algorithm. Here is the list of commonly used machine learning algorithm, and this algorithm can be applied to almost any data problem. Let's look at all of these examples. Right? We have linear regression, sorry, logistic regression, decision tree, support vector machine, and so many more. However, today we will look into one of the common machine learning algorithm that is usually compared to a biological neural network. So artificial neural network is the machine learning algorithm that we are going to go through today. It is being touted as the wave of the future of computing. It is indeed can be a supervised learning or unsupervised learning mechanism which don't require traditional skills of a programmer. But there are many misconceptions which have arisen due to people doesn't understand how artificial neural network work. Okay, some people hype that artificial neural network can do almost anything, and this exaggeration will actually create disappointments for some potential users or me, some of you who have tried, failed, and tried to solve problems with neural network. Thus, it is very important that we know how neural network works. Let's look into the biological neural network first. These are a sample figure of biological neural network that is usually associated with artificial neural network. And most biological neural network will consist of neuron and highly interconnected processor, which is connected by a weighted link. You can read this later, but I want to focus on how we can create our own artificial neural network. Before we can go and create our own artificial neural network, we may have to learn what are the fundamental items or what are the properties or variable that we need to create in order for our artificial neural network to be working properly. Similar to any programmable algorithm, artificial neural network receive input signals to a neuron. All right, so you can see, let me see, okay, sorry. So these are neurons. All right, so neurons. So the neurons is connected by weights, right? So each of the neurons may have bias. We will discuss about this later. Right, so these are the processing elements of a neural network. So the processing elements of the neural network are actually the neurons, which is connected by the weights, these weights, and the neural network will produce an output signal. So the output signal is actually what we want the neural network to do. Either the neural network will do some sort of prediction, classification, identification, or recognition. The input signal may come from raw data, images, videos, sound signals, and many other forms of data. However, before we can send the input signal to the neural network, we have to manage our data first. Our data should be created so that the neural network algorithm can use the data to train itself to become a model, and it will do its purpose. Let's see an example of a simple neural network called Perceptron. So a perceptron are connected by links from input and output neuron, and each link has a numerical weight associated with it. Weight are the basic means of long-term memory in artificial neural network, and they express the strength, or in other words, the importance of the connection between the neurons. So the neural network learns through repeated adjustment of this weight. These are the analogy between biological neural network and artificial neural network. Let's look at neuron as a simple computing element. So these are neurons. These are actually weights, and this is another neuron, and we would usually call this as an output neuron. So the computer creates a new activation level and sends it as an output signal through the output link. The input signal can be raw data, like I said before, or output of other neuron. The output signal can be either a final solution to the problem or input to other neuron. We will discuss about more complex application of perceptron after this. Okay, let's look at this example. The perceptron, in order to produce its output, it will need activation function. So what are activation function? Activation function decide whether a neuron should be activated or not by calculating the weighted sum, okay, which is this one, and further adding bias with it. So the purpose of the activation function is to introduce a non-linearity into the output of a neuron. So as we have already learned previously, okay, this is our output neuron. In order to produce the output neuron, what happens is the value from the input neuron is multiplied with the weight value, and then it is summed with the next multiplication of input times weight value. So these are called weighted sum. So the weighted sum is then sent to an activation function. An activation function acts like a normal programming function or a mathematical function that receives the weighted sum as its parameter. Imagine an activation function receive the weighted sum x in as its parameter in order to produce output. Let's look how the calculation is done. So this is one example of activation function. There are so many other different type of activation function. Okay, and this activation function is called binary step function. So binary step function is a threshold based activation function where the input value, okay, so usually the input value will come from the x axis and the output is the y axis. So the x axis can be any value for the input, like this one. However, the output y is determined by the range of the x axis. If the x value is 0 or greater, meaning if x is a positive value, then the output will be produced as 1. If the x is less than 0, meaning it is a negative value, then the output is 0. Let's look at other type of activation function. We have a sine function that produces a bipolar value either +1 or -1 based on its input. Again, its input is based on the range of x. So if x is 0 or greater, then it will produce 1 as its output and -1 if the x value is a negative value. Similar to step, sine is a threshold-based activation function, and if the input value is above or below a certain threshold, the neuron is activated and send exactly the same signal to the next layer. While binary activation function, binary step, and sine activation, we have a sigmoid or logistic activation function which have a smooth gradient that prevents jumps in its output value. So from the figure here, we may see that the value of output range between 0 and 1 depending on the value of the x-axis. So that again, the x-axis is actually the weighted sum. Alright, you can find other activation function using the given link below, and we will discuss about this later. So before I explain further about Perceptron, we will end this video and discuss further. Thank you very much.